Hey, hello everyone, welcome to the channel. Today we are going to learn about backpropagation. In the last video, we learned about how a neuron works, and that's pretty straightforward. We we just calculate the dot product of the feature matrix, weight, add bias, and after that we apply the activation function and return it. But here in backpropagation, we are we are going to check the changes that being done to each of them. So for that, we'll use something called the chain rule, and chain rule is some sort of something that simulates this one, the domino effect. Let's say I just thrown a block, and there will be certain other blocks that are related to it, and they'll fall one after other. But the block one isn't related to block three, but there is a chain relationship between these three. So that's the same principle we are using it here. And to get a better idea about what chain principle is, let's say I have a company and that company's profit depends on the number of sales I have done, and the number of sales dependent on the number of ads they got. So in simple terms, let's say this is a partial derivative du by dx, and this can be represented like this. So basically what is this is, u is dependent on z, the changes of z, and the changes of z is dependent on the changes of x. We compute these individually and multiply them, and we'll arrive at the relation between these two. So this can be in multiple variables, like here it is 2, then it can be 4, 5, and so on. So this is the chain that is there. So what we'll do with the value we got here, this is the actual gradient function derivative we need. So in gradient descent, we have learned something about this. The x new value is the x old value plus learning rate multiplied by the derivative of f of x. So this is the f of x, and alpha is the learning rate. You guys know what that is. So what I'll do is here I'll do the forward pass or multiply the weights of that, and after that I'll apply the chain rule, and with that we'll calculate the new weights. So the new weights will be like this, and we make all this go through a loop for like 100 or 200, 300, maybe thousands, maybe millions of iterations to arrive at a point where there is less loss and there is no problems like overfitting or underfitting. In the next videos I'll cover what overfitting and underfitting is. So this is basically about chain rule. And for this problem in backpropagation, we need a little help. So we are going to the solution and write the code, and from that I'll help you how to solve this. But before that, this thing is not going to be a straightforward calculation. So basically, in the end, what we need is how the loss is affected by the weights or the input matrix. So this is the loss, and this is the derivative of input matrix, but we can't calculate this directly. So what we'll do is we'll take the dl out of this, and we'll keep the dx out here. And we know there is this thing called activation function, let's call it z. And there is also other thing called yeah, let's take the z here. So what's the missing thing here? What's really is the one that is missing? The one that is missing is the predicted value, that will be dy, and this will be d by 2. So the formula here is this. Let's go to the solution. I'll show you the, yeah, here it is. So for each we'll have different formulas, and z is the predicted value. Z will be this w into x plus b. B is the bias, if you're wondering what b is, and this is the y predicted value, and we know what the x is. So y predicted value will be the derivative of z, that will be the activation, and L, we know what L is. L is the half y minus y square, and we know why we are doing this. And there is also another thing we need to remember, that we need to find a value that is certain or not. Pred- we should take the predicted value, and from that we need to take the true value. Only that way we can find a way to update weights, or else we'll just go in the opposite direction. We are just checking the validity of true value with the predicted value, and that is quite wrong, because true values are something that are constant, and predicted values are always changing. So these are the two formulas that we have to remember to solve this problem. So let's go through the initial step of this, that is doing the forward pass. That is z equal to np dot x comma w plus b. So I got the z value here, and here, to keep things simple, we are showing this back propagation through a sigmoid function. So the predicted value will be like this: multiplied plus np dot xp to the minus of z. If you don't know what sigmoid and relu is, please visit the previous videos. I explained what they are. So here the forward pass is completed, and for the next ones we need to find the error, that will be the y hat minus true. So the predicted value out of the true value, and next up we need to find the derivative of the sigmoid value we have, so that that will satisfy this thing. And let's call it sigmoid derivative, so that we won't be running into silly issues. That will be y hat, that means the predicted value multiplied by 1.0 minus y hat. So that is the derivative value of 1 by 1.0 plus e power minus z. So next up we'll find the delta, that will be error to the sigmoid derivative. So basically, how the math here works isn't similar to the one we do in notes. So we have seen this formula, right? dl by dz. So basically what we'll do is we'll compute the first thing here. So that will make this dl by dz. So how the loss is affected by the sum of numbers, I mean sum of the inputs or the activation, not even activation, how the loss will be affected by the z. So we completed this part, and using this delta we are going to find the value in the end. So we need this value too, and let's call it dl dw, and that will be np dot round delta multiplied by x comma 5. So very simple logic. This dz by dx is quite simple. What we have here is x to the w plus b. So according to differentiation, it will be just x, because we are differentiating with x. These are considered as constants. So like if say we have 2x, the derivative value of this will be x. So in the end, we'll just multiply x, and we are adding this 5 because we have this rounded limit. And so in the end, we got this one dl by dw or dx, whatever we call it. And so we have this one, right? The z. But using the value we got dl dx, we can only update the weights here, but we also need to update the bias, because if the weights change, the bias will also change. So for that, we'll calculate the bias too. That will be dl db differentiated bias. That will be the round of float of delta comma 5. It's nothing, we're just making the delta a float value instead of something that goes beyond imagination. In the end, we'll just return this dlw. The values we got, these are just constants, and the bias value we got. In the end, we change the weights and bias by adding these values. So the weights will be updated and the bias will be updated in the end. And let's run this. I hope it gets submitted. There is a typo. Let me fix that. Yeah, it says sigmodi, and it is accepted. Let's submit this, and it is done. So this is the back propagation, and here we have a table how each of these is calculated. If you connect the dots, we can get into this, and this is the pitfall I'm talking about. We just need to flip the gradient so that we don't go, I mean we don't divide from the thing. And this is not really important when we are training things, but knowing it is important. Implementation is not really a thing that needs to be remembered, because like modern libraries like pytorch just does this in few functions. They just have loss dot backward, and this loop we have discussed is part of a loop that is far greater than this. So this is basically about back propagation, and here we have used this sigmoid, right? This will be a single back propagation. If we are going through multiple values and there are multiple inputs, and we don't have a clear case like 0 or 1, we'll use ReLU, and that will be the next video. Next video is about multi-propagation. And multi-propagation is the same thing we have discussed, but but with different steps. So I urge you guys to remember the chain rule, all the things to understand how multi-propagation works. And thank you for watching. This is all about back propagation. There are other things I may have missed. I'll cover in the next videos. So thank you for watching. Please like, share, and subscribe.